Today we're going to talk about some business applications of calculus. You might have some questions tomorrow, and that's okay. I'm going to talk in general, show you some examples. But first of all, we have a couple examples of cost and revenue functions. Lots of calculus involved in business, whether you knew it or not. Cost, C of X, is the cost of producing X units of a certain product. So this first one, if we're producing 100 units, we can plug 100 into our C function, and it will tell us the cost of producing all 100. Not individually, but the total 100. Marginal cost, on the other hand, is the rate of change in the cost with respect to X. Say we graphed our cost function, and when we do that, this is items made, and this is cost in dollars. So if you notice, this first part of the curve, when it's concave down, this is good. This is efficient use of our money. As you notice, until this point here, as you make more items, the cost increases slower. So that means it costs less and less to make more items. Not that the cost goes down, but the cost of the first item is more than the cost of each item if you make 100 items. So, efficient use. Now, after that point, notice that it changes to concave up. This would be considered inefficient use. All of a sudden, it costs more to make your next item. If you think of these as items, it costs more to make your next item, probably because you had to add machinery lines, employees, buildings to be able to produce that number. And what will happen is, yes, it's inefficient for a little while, but when you get to the point that you can make more, it'll turn and be concave down again, and then you'll grow some more, and so on. So it's kind of a cycle. That as soon as you decide to grow your company, it's inefficient for a little bit until you get to a good number of items that size company can make. And then it becomes more efficient until you reach the maximum amount of items the company can make, and then you have to grow some more, so it gets inefficient again, and so on. So, kind of how that works. Average cost, little c of x, be careful when you write little c of x and big C of x. I like to write them like this, clearly big, and sometimes I write little c really little, so I know whether I'm talking about cost or average cost, is the cost per unit when x units are produced. So, average cost, easy to come up with, is total cost divided by the number of items. If you can make 100 items for $100, the average cost is $1 an item. Does that mean making one would only cost $1? No, making one would probably cost more, and making the 99th item would probably cost less than $1, but it averages out at $1. So, average cost should be a decreasing function. So up to here, this is good, because the price per item is going down as you're making more. Here, you're probably starting to grow again. Inefficient for a little while, but will eventually get efficient again when you get to that amount of items, or a good quality amount of items you can make from the size of company that you have. So, let's talk. If average cost is a minimum, to find minimum average cost, and you can memorize it, we have to set marginal cost equal to average cost. Marginal cost equal to average cost. Now, to do that, we can use our calculator. In Y1, put C of X. In Y2, put C prime of X, or the derivative. You might have that saved in Y2 already, that it's the derivative of 1. And then in Y3 or Y4, if you have something in Y3 that you're not wanting to, you should put Y1 divided by X. and that would give you your marginal cost. So then it works out that cost is in Y1, this is in Y3 or Y4, depending on where you put it, and your derivative is in Y2 in your calculator. So if we plug these numbers in, we get 5,600, 10,600, 17,600, we get 5.60, 5.30, 5.87, and we get $4, $6, $8. So, this says, at what production level will the average cost be the lowest, and what is the minimum cost? Well, to find a minimum average cost, we set the marginal cost, which is 2 plus 0.002x equal to the average cost, which is C of x divided by x. I make this easy. I'm going to multiply both sides by x. And I'm going to, our two x's will cancel out. We can subtract the 0.001x to get 0.001 x squared equals 2,600. X squared equals 26. 2,600,000, which means x, when we square root, is 1,612 items. So that is the production level. But they also want the minimum value. So the minimum value is when we find C of that 1,612, and the minimum value is, little c of 1,612, which is found by taking big C of 1612 divided by 1612. Or you can use the table in your calculator, or your table in your calculator that you already had some of that info in, and we get a value of $5.22 per item. On the back, we're going to talk about a little bit about making money. The front was all about how much it costs. The back is making money. First of all, little p is the demand function, sometimes known as the price function, and we would expect it to be a decreasing function. If there's high demand, lots of people want it, hopefully the price for each one can go down if you're buying in large quantities. Second of all, R of X, our revenue. Now revenue is just how much money you take in. If you have a bake sale and you sell cookies for 50 cents each, your revenue is 50 cents times the number of cookies you sold, just the amount of money you should have collected throughout the day. And so it is X, which is our number of items sold, times our price function. So X times P of X. R prime is the marginal revenue function, or the rate of change of revenue with respect to the items sold, because it could change. Maybe you give a deal for selling a high number. Big P of X is called the profit function, and P prime of X is called the marginal profit function. Now, to find our maximum profit, we need to maximize P of X, which is our money taken in, our revenue, minus our cost. Derive them, set it equal to 0, which is happening here, and we know that our maximum profit happens when marginal revenue is equal to marginal cost. So, let's try one. Here it is summed up for you in a box. If the profit is the maximum, then marginal revenue equals marginal cost. So determine the production level that will maximize the profit for a company with a cost function of 84 plus 1.26x minus 0.01x squared plus 0.0007x cubed, and a demand function, little p, of 3.5 minus 0.001. Well, first thing we need to get is our revenue function, which is equal to x times p of x, or in this case, x times 3.5 minus 0.01x, or 3.5x minus 0.01x squared. And we already have our cost function. To find revenue, we need marginal revenue equal to marginal cost to find maximum profit. So, marginal revenue is going to be 3.5 minus 0.02x. Marginal cost is 1.26 minus 0.02x plus 0.00021x squared. See that squared over there just barely. This is going to be a difficult equation to solve. We can do it. These are going to cancel. And we could graph both sides to find the value. You could subtract the 1.26, divide, and so on. However you go about it, you end up with x being approximately 103 units. Who knows what we're selling, but it's 103 units. And they wanted to determine the production level. So a production level of 103 units will maximize the profit. It will make you the most money.